So, and that's actually an excellent segue talking about tabletop games into what we're doing. It's not Half-Life 3, it's Half-Life Alyx VR. Half-Life 3 is never coming out. All right. So, but anyway, games are a great segue. Um because I've done basically a series of a bunch of I've done two series so far of Monte Carlo approximations. The second of which was going over statistics for Dungeons and Dragons and rolling. Um, so expect on your exam basically to have some dice rolling problems. First off, last semester I had a last semester's problem, which I'll probably give as a practice exam problem this time. What I'll go over that, not probably on Tuesday, was basically what are the chances of rolling. So Monopoly, right? If you roll a double, you get to roll again. But if you do that 3 times, and you can keep doing that, but if you roll 3 doubles in a row, you go directly to jail. So when do you go? So use a Monte Carlo approximation to approximate your the statistics of you rolling a triple and going to jail. So when is the next exam? April 2nd? Yeah, that sounds about right. Yeah, I simply said first week of April last time, so that wasn't specific enough, but April 2nd. So yeah, if that doesn't work for you for some reason, just let me know. I have not posted the practice exam yet because I'm still writing it. In fact, that's my plan for today. I'm going to finish writing it. Um, so I want to make sure. Well, I want more like I want to. I will go over it in class, of course, because that would be terrible if I didn't. I have no idea about course registration. Oh, and if you haven't heard, right on on registration for summer is still open until the 2nd, I believe. So that's been extended. Summer 1 is online. If you haven't heard that, so Summer 1 is now going to be online. It will be held, but it will be online. Uh, for those of you who somehow have taken 1068 and then decided to take this class, I do. I am scheduled to teach 2168 in the summer. So, um, actually, that's a great question. Am I still assigned for that? I find that out in TU Portal. So, but anyway, there are summer classes going on, so if you want to do that, just be aware that they're going to be fully online and that the instructors have now been at least informally notified that they're going to be online. Now, also, how come I am teaching Java next semester? I teach in the summer, but I teach the second Java course. Professor Fiore teaches. So in the fall, it's generally basically I teach most of 1051. Joe Jupin teaches most of 1057. Fiore teaches most of 1068. And then in the fall, I should be teaching 2168, which is the data structures course. So I teach now, and yeah, in the fall I'm scheduled for 2 data structures. So I'll be teaching it in the summer and in the fall, summer 1 specifically. I currently have no students registered, so I might not actually be teaching it. Who knows? We'll see. I don't know when registration opens for it for summer. But with the fall, I will be teaching data structures. For summer, I have no idea. I don't need to register for classes. Why would I know these things? Ah, okay. I must have misread it then. Okay. So. Oh yeah, Happy Feet is eating her food. Very good. Happy Feet is my dog. So now, let's go. So that's with regards to that. With the exam, right? That'll be on the 2nd. It will be online. It will be on Canvas. It will be basically just by virtue of the fact that this is an online thing. It will be online, open note, open book, and open IDE. Basically, if you can use it, open laptop. If you can use the computer, basically open Stack Exchange.
Yes.
But I guess I should say, just please take it on the honor not to try to ask people for help. Right? Don't go and pay some guy on Fiverr to solve the problem for you. Just try to solve it by try to actually search it for yourself. Hi, Laser. You have a poopy diaper. The exam should be a standard class time. I would like you to be on Zoom during the exam, especially since that would be the way that I could actually answer your code. It will be a timed exam, so in the sense that basically there will be a time limit where it is open and when it is closed. If for some reason you cannot make it to the exam because for some reason, yes, I will be proctoring you, but to a certain extent. I will basically, the proctoring will basically be consisting of you, if you need extra time, we work that out because there's different ways to work that out if you need extra time. So, worst case scenario, what I'll do is basically I will have there's a couple different mechanics, like there's an open and close mechanic, so the exam is open here, it closes here, at this time, but you can set up different times for different specific people or different sections. So if you're in a different section of the world, right, or you're, you can then ask questions on here. You will definitely get the full hour and 20 minutes, and I have no problems with extending the time a bit further if you can take it. Okay, I'm just trying to be look, I'm going to say one of those drinking game phrases. This is not ideal, but I'm trying to do the best I can. No, not similar to the last exam. It will more be coding heavy. There'll be a lot more questions that can be auto-graded and a lot more questions that are along the lines of probably coding. If you have accommodations, definitely email me if DRS cannot accommodate you. Nope, this is going to be online. This is going to be completely online, like a quiz on Canvas. Ideally, but you can use your IDE. And I'll try to test it. Worst case scenario, I'll teach you guys how to basically post code in a text box. You can use your idle IDE during the exam. You can use idle, you can use whatever tools are on your computer during the exam. Open book, open note, open tool, open laptop. Just no speaking with other people actively. Right? So no collaborating with your buddy on the exam. That is the line I am drawing. Yes, you can use the internet because you're good. Mm-hmm. Right. We can use anything on the laptop. Basically the line in the sand is no collaborating with another person, no speaking with another person. And I'll be honest, I can't really. I'm going to do my best. I'm going to ask people to have their webcams on for that, or if you're not on the webcam, I'm going to occasionally check your screen, or ask you to show me your screen, or just watch you work, and try to be as unobtrusive as possible. In other words, not really. No, I do not plan on making it more difficult. That's silly. I do plan on accommodating for the fact that basically that there are, I can't really ask you, what does this I have this code, what is the output? Because then, I can't ask you that question anymore, because you can just simply copy that code, paste it, and run it, and oh, there's my output. Those kind of questions just don't work, right? On the other hand, I will ask you, let's go over a question actually from the exam from last semester, okay? That maybe will, let me go ahead and pull it up on my end, and this should actually answer a great number of questions for you. So, all right. Okay, share screen. Share the entire screen. Okay, everybody see this? This is from the exam from last semester. So, this is like you can see over here, exam 2. Okay. So, suppose we had a file called temperature.csv, which contains the daily high and low temperatures recorded in Philadelphia, and these were actually like the actual temperatures for those days. I looked them up. The file is composed of 3 fields per line, containing the date, the high temperature, the low temperature. Each field is separated by commas. For example, the file might look like this. November 11th, 2019, high of 64, low of 40. November 12th, 2019, high of 49, low of 21. And so on and so forth. Right? The ... doesn't mean like there's literally ... I mean like it will have the entries for the 14th, the 15th. You don't know precisely how big the file is, but it's a reasonable size, right, is the idea here. I'll probably give you a couple data fields or something instead, or I'll give you a string that's formatted like that instead so you can copy and paste it. Write a program that calculates the following. 5 points, figuring out which day had the hottest high temperature. 5 points for figuring out the day with the coldest low temperature. And 10 points for figuring out the average high temperature of the entire file. So basically going through the second field, the second field, which is index 1, and figuring out what the largest value is here, figuring out what the smallest value in this column is, and then figuring out the average of all these values in this column. Right, and you could write those as separate programs or one program. I didn't really care. Let me stop sharing for a second. Does that answer, does that give a good idea to you about, the kind of questions we have? And then, there's going to be, so basically it will be, the question basically goes over 3, if I was going to say there are 3 topics on the exam, here's the 3 topics. String manipulation, so basically doing stuff like in Pig Latin and closer to the difficulty of Pig Latin than to Hawaiian Lab, but the Hawaiian Lab and Pig Latin are string manipulation homeworks, right? File reading. So the file reading is like the hurricane assignment, and if you've tried that out, you've hopefully realized it's much easier than it looks. But basically, file reading, I just gave you an example of what file reading was. And then the last was Monte Carlo, which is what we're going over this week. And, I mean, so let's see. So let me show you the Monte Carlo question from last time. Okay, so Monte Carlo, right? In the board game Monopoly, 2 players move around the board by rolling a pair of 6-sided dice. Rolling doubles, such as 2 3s or 2 5s, is great because that you get to roll again, as I've already described, and that basically gives you an extra turn. But if you roll another set of doubles, so which is, the same, it can be the same pair as before, so you don't have to keep track of what pairs you've already rolled. But if you roll a second 2 doubles, then you get another extra turn. But rolling double a third time, you get thrown in jail immediately, and you're trapped until you can roll a double. So my thing said, please write a program that will simulate 10,000 Monopoly turns. Extra rolls due to doubles count as a turn. That was something that a lot of students missed, but I didn't take any points off of it because I felt that, okay, obviously that was a bit ambiguous. But a single roll, but where turn is a single roll of the dice, or if if a user rolls a double. Your program should be able to put out the percentage of rolls where you went without a double, the percentage of rolls that had a double, the percentage of rolls that had 2 doubles, and then 3. And then I broke it down into grading because I wanted to weight it so that the extra credit so that the partial credit would be very, very easy to understand, right? If you can just simulate 10,000 dice rolls, which honestly, that was a freebie for 10 points because that was simply, right, a for loop that ran, 100,000 times and called random dot rand int 1 to 6 twice in the for loop. And that was 10 points. Then handling doubles, checking if your two random numbers were each equal to each other. So the rubric also basically gave you point-by-point directions on what to do. Simulate your 100,000 dice rolls, handle the doubles, handle the 2 to 3 doubles in a row, and then give me the output. Other things will be given, and most of the other questions will be. So most of this will probably be coding. I'm gonna see if I can make it. If I can do stuff that is auto-graded as best as possible. But that's a bit trickier for this class than other classes, so I might just have to. A good deal of this might be coding, but that's okay. And hey, if it crashes and burns, then, well, I know that there's a discussion tomorrow on the university level, basically because there have been a number of universities that have been moving to pass-fail, but I don't know if that's what's going on here. But there's something being discussed so that this semester isn't going to adversely affect GPA, I hear. That's what I hear. And I'm in the committee, so I hear, for a higher up committee, so yeah. So we'll see what's going to happen. Well, I mean, also they have to get, there's also, like, certain amount of I have no idea. I'm just telling you what I hear, that they're discussing, basically, that there's a discussion. Okay? But you'd probably get the news the same time I would, which is through an announcement from the president. I have no idea how it would work. I have no idea what's being discussed. I just know from hearing today that there's something going on, trying to address the whole, outstanding situation and the possible adverse effects this might have on GPAs, and the fact that some professors are terrible and won't accommodate as much as they should. So, all right. With that, any more questions? All right. So let's go ahead and I will talk, and let's do some more. Oh yeah, I'm totally doing office hours today from 4 to 5. So, and if you need to meet me at some other time, just send me an email. It's not like I'm going anywhere. I haven't left my house since I think I got out of the last face-to-face class that we had. Laser is watching Planes, Fire, and Rescue. Okay, so let's go ahead and get started with this. Happy Feet is like a Chihuahua Pekingese mix. Because I'm currently using my, I'll show them at the end of class. Alright. So let's go ahead and talk about Blackjack. Not PY. Okay, I meant to make videos about this, but hey, it's not too bad. And we're going to just use this for Monte Carlo approximation. And we're going to use this to learn more about random. Okay? Oh, the random module. So let's go ahead and see what we've got here. Let's see. Okay. So let's talk about Blackjack. That's what I need to pull up. And then random Python. Great. All right. So Blackjack is a gambling game. And some of you I know might not gamble. Right? I don't gamble because that's silly. Because statistically it's silly. Right? Occasionally I'll buy a lottery ticket just because it's fun, because actually having it gives you the ability to have a nice bit of imagination for $2. But honestly, I don't rely on gambling as any kind of good source of income. However, you may see basically that there are people who stories of people who basically do a clean sweep or something and basically clear a casino with their amazing gaming skills. Very rare, especially in these days. But games like blackjack and poker can be statistically analyzed. However, like I've discussed, counting cards is one way, but we can do a more statistical analysis over here. The thing is that there's a couple things about gambling in casinos. The main thing is that games of chance need to favor the house in some way, shape, or form. It's already being recorded, so no worries. I'm recording it via OBS because it renders so much quicker, and I'll just be able to upload it at the end of class. And it's a higher quality recording. So, blackjack is one of the most popular games in the world. It is an American version of 21. It's played with a standard deck of cards, right? So the cards in a standard deck of cards, by the way, we should probably put them here. Let's go with let's create a variable for that card. Oh, come on. Seriously? Okay. Yep. Good. Thank you. Yep. Okay. Sorry. I was recording it, but not sharing it, which is good. So, blackjack. Over here. Played with a standard deck of cards. Let's go ahead and just list out the cards for everybody who needs a refresher. You've got the numbers 2 through 9. You've got a 10. Right, so actually we'll probably need to make this a list of strings. Or number 2, 3, 4, 5, 6, 7, 8, 9 are your regular cards, and then you've got 10, Jack, King, Queen, and of course the Ace. Now aces. So in blackjack, basically, a lot of these... so we have a deck of 52 cards. So one of the first things we're going to do is actually create a easy-to-use deck of cards for us that's specifically designed for blackjack. But the way blackjack works is fairly straightforward. Players are dealt 2 cards. So you play the game. You sit down in front of a dealer who will deal you 2 cards and himself 2 cards. The dealer will receive 1 card face up, so you get some information about what the dealer has. Your cards are face down, and you can kind of look at them. The dealer gets to look at his, but the dealer follows an algorithm, a very specific algorithm that are announced basically ahead of the game. And basically, we're going to concern ourselves with basically only the 2 most basic rules of blackjack, which is you can either hit or you can stay. Hit means you get another card, and staying means you are good with your value. And now the goal is to get as close to 21 without exceeding it. The minute you exceed 21, you automatically lose. So you might get, say, a 15, and you might want to figure, okay, well, if I get a 6, if I've got a 15, if I receive a 6 or lower, you get closer, and if I get a 7 or higher, I'm gonna go bust. Right? I'm gonna lose. So the question is, what should I do? So the rule typically is that the dealer will always hit until they have at least 17 points, and then they stay. There are also some automatic things you can do, which is a blackjack, which is when you get basically 21 off the bat, an ace, and a card that's worth 10. So each of these cards have a value. Jacks are worth 10 points, kings are worth 10 points, queens are worth 10 points, number cards are worth the numbers that are on their face. Aces, on the other hand, follow a special rule, which is that aces can be worth either 1 or 11. And that just simply depends on what's more advantageous, 1 or 11. And if I've completely messed up the rules of blackjack, please let me know. Now, the big thing about this is that Um, as I mentioned, games in casinos, they need to favor the house in order for them to be profitable for the casino. But here's the thing. Uh, with the standard rule, a lot of the rules for blackjack, there are edges. You can basically depending on the rules, the player can have an edge. In blackjack, which is why we are going to look at it. So let's go ahead and first generate a deck of cards. Now, we don't really care about jack, king, queen, or ace. What we care about is the numerical values, right? So what I'm going to do is I'm going to consider the jacks, kings, and queens to all be 10, and the ace to be an 11. Okay? Make sense to everybody? So basically, I'm just going to plug in the values instead. So a jack is a 10, a queen is a 10, and a king is a 10 as well. And then the ace, I'm just going to consider that to be an 11. What am I doing? Yes. There's a question here in chat. But what about when aces are ones? Good question. We will handle that because most times because generally we want aces to be 11s unless they would make us bust. So that's what we're going to do. We're going to treat aces as 11s unless they make us go over, in which case we'll treat aces as ones. That does sound annoying. So, all right. Let's go ahead and figure out So let's go ahead and generate a deck. Because we're going to need to generate a lot of decks to do this. Gen deck. Def. So the first thing I want to do is that I want to basically make a new list. So a deck is equal to card types times 4. Now that looks kind of cool. It kind of would have its own if statement, depending on how we do this. So we'll go ahead and print the deck out here before we move on, because I want to make sure that I want to make sure this works just the way I hope it would. Not print deck, but print gen deck. Keep spelling desk. So we've got, as you can see here, by multiplying by 4. Now, why did I multiply by 4? Because we have 2 through 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cards here. And then there's 4 suites for every card. So there's 4 copies of every card in the standard deck, right? So just reminding you, because I'm sure you've all played with the standard deck of cards at some point, but reminding you if it's been a while. So we've got all those cards, and honestly, the suits of the card don't really matter. So let's go ahead and then, so now we just got to make sure that basically that this, I just need to make sure of something. Print 0, sorry, deck 0 is equal to 20. This is just me being silly and just double checking something. Good, okay. I was worried that that Python was going to be stupid or something here. Okay. So, but no, it works exactly the way I think it does. So we've got now a deck of cards, but how do we shuffle a deck of cards, right? Because while we've got a deck, we can sort it and put it in order, but we actually want to kind of do the opposite. We want to make it disordered. Now, there's a lot of different algorithms for sorting, but honestly, for shuffling, but honestly, I'm just going to use the one built in the system. Essentially, so you can throw random shuffle sequence X in place. So basically, we can just say, hey, import random. Random.shuffle deck and print deck. And now we'll see that basically, yeah, it looks like there's a lot of clusters of 10s, but that's because, remember, the 10s occur basically basically are overrepresented because you've got 10s, jacks, kings, queens. I don't know why I keep putting the kings before the queens here. Patriarchy, maybe. So this effectively does shuffle our deck for us. So we'll just simply create this tiny function just so that we'll have it later. Return deck. And now, here's the thing. We need to deal our card. We want to see what it is to deal. Let's look at dealing cards. So deal, deal hands. N is equal to 1, where N is the... You know what? We're just going to assume that there's one player for right now, so no need for that. So what are we going to do to generate this? So first we're going to get our deck of cards. Generate our deck of cards. Right? Alright. And now the question is, anybody here know how cards are dealt in... How are cards dealt in Blackjack? Like the order. Who gets the first card? It doesn't really matter, but I do want it to be statistically... I do want it to be identical. Statistically, it really doesn't matter. But, dealer goes last. So, and it's one card, and it's one card, then another card, then one card, then another card, right? So I get my first card, then the dealer gets his first card. Great. It doesn't really matter for the stakes of statistics because one card could easily... Yeah. Well, we're only going to have one player right now, so that doesn't really matter too much. So what we're going to do, we're just going to look at player and dealer. So player is equal to... So player is equal to this list. Dealer is equal to this list, and so basically we're gonna get the first four We're going to get the first 4 cards of our deck. Okay. So now let's see. So, and we're gonna do a lot of things to see if basically the statistics change at all. So dealer. So we've got 52 cards here, so we're going to go and say, so 4 I in range. Actually, no need to do a range or anything. Yeah, 4 I in range. Let's do that. 4 I in range. 0 to 4. So we're going to go up to index 3 on this one. And so players get the first card, so we're going to say... Actually, yeah, we just need... I'm just going to do this twice. So what I'm going to do is say player dot append deck I dealer dot append deck I plus 1. And I'm doing this way just so I can teach this, right? So what's going on here? I've got I, which has 2 values, right? And a player gets dealt, everybody gets dealt 2 cards. So I'm dealing 1 card, then another card, then 1 card, then another card. That way everybody's going to get 2 cards. So the player gets card I, then the dealer will get I plus 1. So he'll get 0, then the dealer will get 0 plus 1. Oh, yeah, that's not going to work. Because then I would get 1 and the dealer would get 2. So we need 2 times I and 2 times I plus 1. Okay, so what's going to happen now? I'm going to get... So I will be 0. So player will get card 0. I'll be 0, so player will get card 1. So dealer will get card 1. Then I will be 1. player will get 2 times 1 because we're dealing out 2 cards. I'm explaining that right now. So since we're doing 2 times 1 for our second number, I'm going to get index 2, and then dealer will get index 3. Make sense? So, right? So this will give me the cards at even indexes. This will give the guy cards at odd indexes. It'll give the dealer the card at the odd indexes. So another way to do this, if this is confusing, is that we could just simply do it like this. We could say so if I mod 2 equals 0, if it's an even card, give it to the player. Player.append yeah. It was just a nice, concise way to do it, but honestly, I realized that was probably confusing. So, deck I. The answer for that is because math and the way that the for loop needs to work. But all I'm going to say is that now, if it's an even number, give it to the player. If it's an odd number, give it to the dealer. Right? Because it'll go to the player, then it'll go to the dealer. It'll go to the player, then it'll go to the dealer. It alternates. Alright? And then the next thing we need to figure out is what is the value of a hand? Right? So I'm going to deal a hand. Def hand value. So here, right, what I've done is that both the player and the dealer have gotten their hands. So I can return player, comma, dealer to give both players, to give both those back. Now, if we want to compare those to see who would be doing better, before we talk about any kind of strategy or something, we're just looking at opening numbers, then we need to have a way of figuring out what the hand value is. Right? And it doesn't need to be 2 cards. It can be like 3 or 5 or whatever. Right? So, here's what we're going to do. Basically, we're going to add up the cards and figure out what the value is from there. There's a couple rules, though. If we break 21, if we're greater than 21, we're going to say that the value of the hand is 0. Because that way we'll be able to show basically that this player lost. If on the other hand we've got aces, well, if we exceed 21 and we have aces, we'll figure out something else. So, let's go ahead and do this then. So, def hand value hand. So let's go ahead. So if def value hand. So what we'll do is we'll go ahead and just simply say total is equal to sum of the hand. So sum basically just sums up all the numbers and just gives it to me as a single number. It's very useful, single line, so avoids having to write a for loop. If total is less than 21, if total is less than or equal to 21, then I don't really have to do anything. Don't have to care about the aces because I don't have to count any of the aces as 1 because it's still perfectly fine. Okay, so return total. Okay. Now let's go ahead and think about how we're going to do ifs, because that's what I've been thinking. Yes, that is less than or equal to 21. My font does fun things. Less than, equal, boom. Just like that. I use a font called Fira Code. And it provides ligatures. So Ligatures are typically, font ligatures are typically like this. Don't get me started. You got me started on font. That was a bad idea. Fonts with ligatures are, so here is a classic ligature, the the long S or I, or, I've said in other type, this is one you'll see in books often, FI, about fire code is, from this point forward asking about this is legal, right? But the point is that basically that's baked into fonts, and then fonts, and then basically there are programming fonts that decided to like in the past decade to take advantage of stuff like that. And I like it for readability's sake. So, if we're less than 21, that's great. Otherwise, we are exceeding 21. So, what we're going to do is that basically, if there's aces in there, we're going to say, while 11 in hand. So while there's still an 11 in the hand, what I'm going to do is I'm going to say total is equal to, I'm going to say, what I'm going to do is that I'm going to say, let's see, while there's an 11 in hand, let's see. Well, yeah, I'm just trying to think of the best, most efficient way to show you this. So while we have an 11 in hand, what I'm going to do is something a bit aggressive. I'm going to say, hey, give me hand.index of 11. That'll give me the first index of what contains an 11, right? Which is an ace. That'll give me the first. Did we define hand? It's up here. It's just a list of numbers. We will define hand, but it's going to be one of these things that we get from generating a deck, from generating a hand, and then dealing it, and then doing hitting and staying. But right now, we're just going to. What I plan on doing is just looking at the. What do we get when we? How often we're going to get certain results when we on opening hands. So delete. So hand. Well, we're going to find the first index of. So we're going to find where the first ace is in our hand, and then we're going to say, hey, hand target is equal to a 1 instead. We're going to. When do we change the strings into integers? Already did.
You want it to be a train?
They're all integers right now. It's all integers all the time. Why are Jack, King, Queen marked as 10, 10, 10 respectively? Because there's no difference between Jacks, Kings, or Queens. They're all worth 10 points in Blackjack. So they're just simply represented as 10s. So this way I don't need to translate anything from strings to integers. We can just worry about integers. So what I'm going to do is I'm going to find the first ace in my hand, replace it with 1 instead, which is the optional, which is the other value for that, and I'm going to return, and then I'm going to say total is equal to sum of the hand. So find the first ace, treat it as a 1, and then figure out what in the world the value is. Okay? And then I'll ask again, if total is less than 21, I'm going to return or equal to 21 total. So what if person has a 10? It can, but for right now, that's not what I'm going to be looking at. I'm looking at raw numbers right now. Actually, no. That might be the case if you're playing friendly, But you got to beat the dealer to win your bet. So, so yeah, you have to win. You can't tie. You got to win. So, else return 0 because we busted. If the hand has 2 aces, will they both turn into 1s? No. Only if we need to. Only if we end up with something like a jack and 8, so we're up to 18, an ace and ace and ace. Those will all turn into 1s at that point. But if it's a jack, but basically if it's a ace, an ace, and a 9, that will add up to 21. The reason being is that we're asking, while there's a 21, replace the... So we're asking, is there a 21? Is there an ace in here? Is there one or more aces in here? If there is, I'm going to find it, replace it with a 1, and then add it up. And if that's less than 21, that's great. It's a legal hand now, so boom. On the other hand, if it's still above 21, I restart this one and say, hey, is there an ace I can reduce? Why replace with a 1? Because aces can either be counted as 11 or a 1. And generally, it's better to consider an ace to be a 1. So what determines the value? It's greed, essentially. We always want cards to be the highest possible values. So essentially, we're going to assume it's an 11 unless it busts us. Why is this in front of the if statement? Because if there's no 11 in here, then we'd never enter this. Because if there's no 11 in here, we don't enter this. So basically we're saying, hey, if it's just going to add up to... And also, if there is an 11 in hand, I don't need to necessarily do that. Target is the index of the first ace. Whew, you guys ask a lot of questions like this. Like, it's amazing. I've never gotten this many questions from people. Well, aside from all the other times I've done online lectures with you guys. I'm not saying that's a bad thing. I'm just remarking that this is amazing, and I should probably have a group chat going in my... Yeah, I should probably have a group chat going in the lecture in the future, just so that people can type questions. That seems to be a lot... Oh, right. So pedagogical discovery made here. Did you hear that at all, Annie? Nope. Students are way more willing to ask questions in chat than they are in lecture.
Write a paper.
Mm-hmm. Yeah, my wife says I should write a paper on this. I need data then. Okay. So. Yeah, I know. So, let's go ahead and I do have... All right. So with this, what we're doing here is we're saying basically, okay, if my hand does not bust without making any changes, I'm going to keep it. If on the other hand, otherwise, I need to make changes or I immediately lose. And the only thing I can make changes in my hand is treating the 11 as a 1 instead. And so that's what we do here. We say, find where the first 1 is. That's our target index. We replace that with a 1. Add it up. If it's less than 21, return it. And if none of that works, then I'm just going to have to return 0. Oh, I have an else after a while. By the way, that's totally legal, but I'm just going to do return 0 by default over here. Okay, there we go. So now what we can do is that we can say deal hands player dealer is equal to deal hands. I can now print, and what I'll do is I'll print out the player and hand value of the player. And then we can do the same for the dealer. All right, and right now we're just looking at immediately just dealing the very first cards, and I'm not even looking at basically, that's for the dealer. And we'll deal with hitting and stuff later. We're just looking at opening values right now. So right now I'm just looking for 11s, right? No, so 7, 11, boom, it's an 18. So now let's go ahead and say, hey, let's just go ahead and see, let's just go ahead and print out an example hand. Dealer, sorry, hand value of 7, 11, and 9. And that shouldn't bust. That should be 7. That's 17 because the 11 gets turned into a 1. And then if I do it, if I hit again and give myself a 1 there, boom, it's 18 as well. So yeah, isn't there some rule? So the question was, isn't there some rule your card needs to add up to at least 16? I believe that's just for the dealers. They have to have a there's a specific algorithms dealers have to follow, and that depends on the casino and the table you're playing and specific rules. So let's go ahead and figure and see how many of these that. Let's just simply look at the distribution of values that I'm going to get. So values is equal to gen deck. Or not, sorry, value is, sorry, players, dealer. Let's go ahead and do this. Trials. Let's do 100,000 of these. Actually, let's start at 10,000 because I'm not sure how long shuffling takes. So for blank in range trials. Player dealer deal hands. So we are going to deal hands. Let's go ahead and actually let's go ahead and move this out of here. Say we're going to give it a deck of cards, deal the hands from it, and then return player dealer, and then deck. Yeah, we'll just simply do that. Player dealer. Deck is equal to gen deck. So generate a deck, deal the hand from the deck, and then we're just going to simply keep a count of all of our results in a dictionary, right? So play, and what we care about is what the players got, which is, so let's go with, say, hand value of player is, the score is equal to the hand value of the player. If hand value is greater than, if score is in deal hand, if score is in count, that's what I'm looking for. We're gonna get dealt a hand, gonna calculate how many points it's worth. If we've seen this score before, then we've seen it one more time, so we're gonna say the count of this score that we're keeping track of, count of score should be increased by 1. That's just increment that by 1. It's nice and short. Otherwise, I haven't seen, this is the first time I've got dealt a hand that added up to this score. So that's the first time I'm keeping track of it. Now to print it out nice. For score in count. So this is the nice way to do it sorted. Sorted count dot keys. I will upload this on GitHub. So Yeah, yeah, the player isn't required to do anything. The player is allowed to be an idiot. They're also allowed to be as smart as they need to be. So, 4 score in sorted keys, print. Score. Count. Score. Divide by trials to get the number of times this ran. So what this did is that this sorted all the keys that we'd put in there. So we went through them, and now we printed them out. So let's go ahead and take a look at the statistics. Let's see, it's too big. Let's center it in the screen again. Okay, so the lowest possible thing you can get is 2 2s. So and that required you getting basically, and the statistics say that is less than a. So let's go ahead and actually make this a percentage to make it easier to read. Times 100 to turn it into percentage, and plus, and then let's turn this into an str to turn it all into a string, plus parentheses, no, sorry, percentage sign, not parentheses, and then sep is equal to tab to make it nice. So now it will be nice and indented and all even and stuff. And it's now, so let's look at our percentages. So you've got a 0.43% chance of getting a 4 You've got a 4% chance, apparently, a 4.5% chance, 5% chance. Let's go ahead and get, so that's some variation right over here, which means getting differences of that much means we have not done enough trials to be statistically significant. So let's do some more trials. Let's do 10 times as many. Okay, that seems, so 4.7, right? So these results seem to be a bit more consistent. There's still a percentage point difference between that. But let's see, we've got a basically 0.5% chance of basically getting the worst possible thing. We've got a 4.8% chance of just winning outright. We've got a 1 in basically what amounts to about a 1 in 20 chance of just automatically winning the bet for the round, which is pretty awesome, right? That kind of appeals to you, even if you know. Oh, and then there's a 10.3% that you do so. There's a 10.3% chance though that you get a 20, which is pretty close, and 19. Honestly, these are pretty good numbers here. I'd have to take a look at your code to see why type error none type is not subscriptable. You possibly have not initialized something that you're trying to grab an index out of. But we don't just play with opening hands. Basically, so let's go ahead and take a look at this. The strategy. The dealer has to. So basically, let's go back to our deal hands over here, and let's add in the hitting and the whole concept of hitting. Okay, deck is. So what I'm going to do here is I'm going to say deck 4 to the end. So we took out the first. Yes, I will definitely be uploading this code after class to GitHub. So you can find that linked on Pages. So deck 4 to the end. So basically we're going to slice off the first 4 cards of deck because we just dealt them to the players. Okay? So now we have to go through the player strategy of basically of what the player is going to do. Right? So anybody want to present a very simple strategy? And now the reason I say a very simple strategy for Blackjack is because here's the chart basically that you can memorize for any basic strategy, which is that will minimize what you need to do. If you got an 18 to 21, and this is the card you can see on the so basically given your hand score, and what you can see the dealer's face-up card is, this is what you should do. So, and what does DH mean? Well, there's other things you can do. You can double down, and you can also split. So, hard totals excluding pairs. So in other words, so there's certain, what's a hard total? I believe that's with a, oh, that's just if you, what is hard total? Doesn't really say. I assume that's basically if we get this. So I assume this is basically if you with your what you're dealt. If somebody knows what's meant by hard total, please let me know. But if you've got these are basically the statistically best moves to make. If there's something that can be done called splitting, by the way. There's also something called surrendering that you can do. But basically, let's go ahead and make it a much more. And this doesn't even take into account card counting. So let's go ahead and make a basic strategy for our player. Let's say if our player's strategy is, yes, I will be uploading this code somewhere. Let's go with the basic strategy of if my player's score is less than 16 hit. Otherwise, we're gonna stay. Okay, and the dealer will go with the strategy of if they're greater than 17, if they hit until they hit a 17 or more. We're gonna go with 16 or more. So player is equal. So what we're gonna do is say while hand value of the player is less than 16 and hand value of player is not equal to 0. Okay? So while the player has less than 16, a score of less than 16, and he's not busted, right? That's what this means. And not equal to 0. We are going to say player.append. I typed not equal by doing a exclamation point and an equal sign. And then this is why I like this code, because it's so much easier to read. Not equal. At least it is for me. Okay. So now we're going to append player. Sorry, we're going to append deck. We're going to grab the deck. So while our hand is less than 15 and we haven't busted, we're going to hit, which means we're going to get the first card off the deck. And then deck is equal to deck from 1 to the end, so we're going to slice that card off. Similarly, no, it's pound equals. Again, fear code doing something. So it can ASIM one or more cards totaling 6. So while the hand of the dealer is less than 17, dealer is less than 17, and the hand value of the player is of the dealer is not equal to 0. Dealer. So there we go. So now, we're going to deal. So we're going to generate our deck. We are going to do player dealer. We're going to deal our hands from the deck. And now we're going to compare, hey, if, so let's do a different count here. So we'll count up the score for the player like normal, but also we're going to have wins is equal to 0. If hand value of player is greater than the hand value of the dealer, wins plus equals 1. Right? So if we, and then we will print out, what we're going to do is we're going to print out all these results. Sorry. There we go. We're going to print out all these results. And then we're also going to print wins divided by trials times 100 to figure out what our percentage is. Okay, well, it didn't crash, so that's good. So, as expected, what we're saying here is that we, so as expected, because we told the player hey, if you're below 16, hit, we don't have any score that's below 16. So, 13% of the time we got a 16, and fairly uniformly distributed over here for 16, 17, 18, 19, about equal chances there. Higher the highest chance is getting a 20, and then a 21% chance, then 11% chance of getting a 21. But we're only winning 41% of the time with this strategy. So let's go ahead and see if we follow the same strategy. And again, we're not comparing for title, for ties. We need to see if we're winning straight out. So we actually possibly went down that time. We're certainly busting more often. See that? 20% of the time we busted in so we busted 20% of the time with 16. But if we go up to 17, if we hit when we hit 17, if we hit while we're below 17, we're going to bust 28% of the time. And thus we're going to lose a bit more as a result. So, and this is why basically so these strategies are okay, but the house will win more, which is what matters to the house. Because the house, you just need to stop once you're on some point, but the games never stop playing for the house, so they'll win in the long run. That's okay, even if somebody wins big at some point. Okay. Now there's other couple things over here, which is that we're also making the assumption that every time we play a game of poker or game of blackjack, that we are taking out a brand new fresh deck, shuffling it up at random, and then playing with that brand new fresh deck. But generally what happens, right, as I've been showing you over here, is that the deck gets replaced. Right? So, so that's something to consider. And I think in our last 10 minutes of class, let's consider this. So basically, let's go ahead and say, hey, basically, if deck, if length of deck. So let's go over here and just add in some if statements over here. So if length of deck is less than 4, if there's less than 4 cards left in the deck, what we're going to do is say deck is equal to deck plus Yeah, we'll do it this way. We'll say deck is less than deck plus gen deck. So we'll take another fresh deck out. We'll shuffle it and tack it on the back. And then over here, what we'll do is we'll say if length of deck is 0, deck equals gen deck over here. So now we're going to simulate this a bit more realistically, which is playing multiple games, okay, using the same deck. So as a result, I'm going to be making, there's a number of changes I'm making. First and foremost is that I need to return this deck because I'm replacing the deck with essentially a new deck every time I do this. So if I'm passing it in, I want to pass it out as well. And that's something I plan on going over in one of those videos that I really want to go over. That's not Blackjack, so because I want to make sure you understand that. It's probably well rooted in the runestone, but I'm going to go ahead and go over it. So gen deck. So here, what instead we're going to do is that we're going to generate our deck out here. So we generate our first deck out here. We pass it in, and now we we say, hey, deal hands using the deck. And now the player has cards, the dealer has cards, and here's the remaining cards. Okay? And then we go through and play. And now over here we say, hey, if the deck has less than 4 cards currently, then we will just randomly generate so that more cards so it never runs out. Same thing with over here. Generate. So here, this removes cards. Less than 4. Actually, what I should need to be doing is basically
Daddy, the house moves.
The house is moving.
And mine too.
That is very interesting that the house is moving. Okay. Actually, we are going to run into a problem over here that basically that will remove 4 cards. There's less than 4 cards in the deck. So if there's exactly 4 cards in the deck, though, yeah. So here, just in case, if there's exactly 4 cards, we'll generate more as well. So here, it's going to go faster. And the statistics turn out to be about the same, even if we make the game simulation more realistic. Is there a limit to how many cards can be in a deck at once? Kinda. But I mean, the idea here is that as soon as we get to an end of a deck, we're basically reshuffling. Also, at least in basically we're simulating the whole shuffling thing. Another way we can do that is that we can remove the lengths of the decks over here and say, hey, if the deck is at half capacity, then we change it up. But honestly, it doesn't really seem to change the statistics all that much. That's what's important here. It's not changing the statistics. So, anyway, but this is, you can see here, this is, again, Monte Carlo methods applied on a gambling game. Right? And we can use Monte Carlo methods to approximate all sorts of things. Right? Because the statistic, again, you know, if there's one big thing about Blackjack, right, that, you know, we can analyze it using statistics and stuff like that, like going to card counting. See, there's different systems. Very little about actually the mathematics. But honestly, if you want the easy statistics and the easy mathematics, just simulate the thing that we're trying to figure out and see what happens. That's what Monte Carlo approximations are all about. So I'm gonna go ahead, and I think this is a great place to stop since we're out of time. So I will go ahead and upload this right now in front of you. Hyper. So boop 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 boop. So share screen. CD. Git add star.py. Git commit. And there, it's on GitHub.
Where'd your water go?
Are we submitting anything today? No. Okay, you want me to show you Happy Feet? Give me 1 second. So, give me 1 second. Exit. I need to exit face rig. Give me a second. Where's my face rig? It's over here. That's my dog. Hey.
I heard her cue coming, so I brought her over.
Everybody says you're a cute dog, Happy Feet. Actually, Happy Feet's a girl, and she is... How old is she? We have no idea, but she's old.
At least 12.
She's at least 12. Where is GitHub? Excellent question. So, GitHub, you can find it on Canvas under Pages, but let's go ahead. But I'll go ahead and show you online where you can find it. So, share my screen again. GitHub.com. So I am A.B. Rosen on GitHub. You can find all the code I kind of do in class over here. Oh, cute cat. People are showing their pets now, Annie. All right, so you can find it over here, and then Classroom is what you want. So Classroom, and then ITP for Intro to Python, and then Spring 2020 for all this stuff, and you can see when it was last modified.
Where did you leave your drink laser? Did you put it over there?
This would be a... It's a her. The cat is a girl. My dog is female, and a pirate because she's missing an eye.
No, it's not downstairs.
How do you get on GitHub? You just go to github.com. A.B. Rosen, Classroom Tree Master. Or you can go to Canvas. Go to here. Go to our class. No, we don't have to submit the code. This is just this was just a normal lecture today. And probably tomorrow will also be a normal lecture. Whoops, whoops, whoops. Not grades. I don't want grades. Let's see. Here we go. Be annoying. Be on Pages. So Pages, if you click on Pages, go to class code. You'll find a link to basically to the GitHub I just showed you. And you just go to ITP for Intro to Python. And the code I've been doing all semesters up there. All right. See you guys. It should be up. Okay, and I'm about to upload this. So Yeah. This would be an exam question, but shorter. This is very much like the Monopoly question I showed you was very similar. I will publish the office hours link. So let me go ahead and publish that and end the lecture so I can get ready for office hours. All right.